Imagine looking up at the night sky. The stars feel quiet, distant, almost permanent. For thousands of years, humans have looked at the same sky and thought it never changes. But the universe is not still. Right now, at this very moment, our home, the Milky Way Galaxy, is slowly drifting through the darkness of space. And far beyond it, another giant island of stars is moving toward us, the Andromeda Galaxy. A galaxy filled with hundreds of billions of stars, entire solar systems, maybe even worlds like ours. And over the next few billion years, these two vast galaxies will begin a slow cosmic encounter. But here is the strange and beautiful part of the universe. When galaxies collide, almost nothing actually crashes. So what really happens when trillions of stars, clouds of gas, and dark matter pass through each other? To understand that, we have to imagine the universe moving in slow motion. Look up at the night sky for a moment. At first, everything feels still. The same stars, the same quiet darkness, the same glowing band stretching across the sky. For thousands of years, humans believed the heavens were unchanging. But the universe is not still. It is moving, slowly, quietly, on scales so large that we almost never notice. Our home, the Milky Way Galaxy, is not just a group of stars you see at night. It is a vast cosmic city, hundreds of billions of stars, each one a sun, many with planets orbiting them. And our own sun sits quietly in a small neighborhood called the Orion Arm, far from the busy center of the galaxy. But out in the darkness of space, far beyond the edge of our galaxy, there is another giant island of stars. The Andromeda Galaxy. It is enormous, even larger than our own galaxy, stretching across about 220,000 light years. Inside it are hundreds of billions of stars, entire solar systems, clouds of gas, and mysteries we are only beginning to understand. And it is not standing still. Right now, at this very moment, Andromeda is moving toward us. Not quickly in human terms, you wouldn't see a change in your lifetime, but across cosmic time, it is inevitable. Every second, the distance between the Milky Way Galaxy and the Andromeda Galaxy becomes just a little smaller. And in about 4 to 5 billion years, something extraordinary will happen. Two gigantic galaxies, each containing hundreds of billions of stars, will begin a slow gravitational dance. But here is the surprising part of the story, the part that makes the universe so strange and beautiful. When galaxies collide, they don't explode like cars in a crash. They flow through each other. Stars drift past stars. Gravity pulls and stretches entire spiral arms. The sky itself would slowly transform into something no human has ever seen. So the real mystery is not just that these galaxies will meet. The mystery is this: what actually happens when 2 trillion stars pass through each other and a completely new galaxy is born? Now imagine something simple. 2 clouds floating slowly across the sky. At first they look solid, almost like objects that might crash into each other. But when the clouds meet, something interesting happens. They pass through one another. The shapes stretch, swirl, and blend together. But the tiny droplets inside the clouds rarely collide. Galaxies behave in a surprisingly similar way. The Milky Way Galaxy and the Andromeda Galaxy may each contain hundreds of billions of stars. That sounds crowded. It sounds like a place where collisions must happen constantly. But the truth is almost the opposite. Galaxies are mostly empty space. The distances between stars are so vast that even when 2 entire galaxies drift through each other, the stars themselves almost never collide. To understand this, we need to shrink the universe down in our imagination. Suppose our sun were the size of a grain of sand sitting on the ground. Where would the nearest star be? Not across the street, not in the next city. It would be thousands of kilometers away. That is the scale of emptiness inside a galaxy. So when the Milky Way Galaxy and the Andromeda Galaxy begin their slow encounter about 4 to 5 billion years from now, something remarkable happens. The stars mostly slide past each other. Entire solar systems drift by like ships passing quietly in a vast cosmic ocean. But while the stars rarely collide, gravity is always working. Every star pulls gently on every other star. Not enough to cause instant chaos, but enough to slowly reshape the structure of both galaxies. As the galaxies approach, their beautiful spiral arms will begin to stretch and distort. Stars will be pulled into long, glowing streams that extend hundreds of thousands of light years into space. Astronomers call these structures tidal tails, enormous rivers of stars flowing through the darkness. Some stars may be flung far away from the galactic centers, wandering alone through intergalactic space. Others will fall inward toward the dense cores of the galaxies. And as clouds of gas collide and compress, something new begins to happen. New stars are born. Brilliant blue stars ignite in huge clusters, lighting up the merging galaxies like cosmic fireworks. For millions of years, the sky inside these galaxies would glow brighter than ever before. Not because of destruction, but because gravity is reorganizing the universe. Slowly, patiently, beautifully. The first pass of the Milky Way Galaxy and the Andromeda Galaxy will not be the end of the story. After they drift through each other, gravity will pull them back together again. They will swing apart, then return again and again, like two dancers moving in slow motion across billions of years. Each encounter will pull more stars out of place. Each pass will blur the elegant spiral shapes that once defined the galaxies, until eventually, after hundreds of millions of years of gravitational motion, the two galaxies will no longer be separate. They will become one enormous new galaxy. And from the inside, any observer watching the sky would see something astonishing. A universe that looks alive, not frozen in time, but moving, changing, and evolving on the grandest scale imaginable. When the Milky Way Galaxy and the Andromeda Galaxy pass through each other for the first time, gravity will continue to pull them back together. They won't simply merge instantly. Instead, the two galaxies begin something like a slow gravitational dance. They drift apart. Then gravity pulls them back again. Each time they return, their shapes become less like the elegant spirals we see today. The long spiral arms stretch, twist, and gradually dissolve into enormous streams of stars. Imagine stirring two glowing whirlpools of light together. At first you can still see the separate shapes, but slowly the patterns blur. The motion mixes everything together until the original spirals disappear completely. Over hundreds of millions of years, the stars of both galaxies begin to settle into a new gravitational balance. The structure becomes rounder, smoother, calmer. Astronomers believe that the final result will be a gigantic elliptical galaxy, much larger than either galaxy we see today. This future galaxy is sometimes given a playful name, Milkomeda, a combination of the Milky Way Galaxy and the Andromeda Galaxy. Inside this new galaxy, trillions of stars will orbit a shared center of gravity. The chaotic motions of the merger slowly settle down. The enormous tidal streams of stars fade into the background, and the galaxy becomes something quieter, older, more stable. But during this transformation, many stars, including possibly our own sun, may be moved into completely different parts of a galaxy. Our solar system might drift much farther from the crowded center, or it might be thrown into a new orbit far out in the outer halo of the galaxy. Imagine the night sky from such a place. Instead of seeing a bright band of stars across the sky, the galaxy might appear as a soft glowing cloud surrounding us in every direction, a reminder that we now live inside a much larger cosmic structure. And here is the most fascinating part of the whole process. Nothing in this transformation happens quickly. The birth of this new galaxy unfolds over hundreds of millions of years. To us, that sounds like an eternity. But to the universe, it is simply another step in its long story of change. Galaxies form, they interact, they merge, and from those encounters, entirely new galaxies are born. So the meeting of the Milky Way Galaxy and the Andromeda Galaxy is not really the end of two galaxies. It is the beginning of a new one. The chance that our sun directly collides with another star is extremely small. In other words, Earth will most likely survive the entire event. Our sun will continue shining. The planets will continue orbiting. Life, if it still exists then, might not feel the collision at all. But something extraordinary would happen above us. The night sky would slowly transform. Over millions of years, the the Andromeda Galaxy would grow larger and brighter in the sky. What is now a faint smudge of light would eventually stretch across the heavens like a glowing spiral river of stars. As the galaxies interact, long streams of stars would arc across the darkness. Clusters of new stars would ignite where clouds of gas collide. The sky would no longer show a single band of the Milky Way Galaxy. Instead, it would be filled with swirling galaxies, brilliant star clouds, and glowing structures stretching across space. For anyone standing on Earth during that distant future, the night sky would become something no human has ever witnessed before. Not a quiet sky, but a sky alive with the motion of two galaxies becoming one. When we look up at the night sky, it feels timeless. The stars seem quiet, fixed, eternal. But the universe tells a different story. The Milky Way Galaxy is not standing still. The Andromeda Galaxy is not standing still either. Across billions of years, gravity slowly guides them toward one another. Two vast systems of stars, gas, planets, and mysteries moving together in a cosmic dance. And one day, far in the future, they will no longer be two galaxies. They will become one new galaxy, born from motion, gravity, and time. It reminds us of something important about the universe. Nothing is truly frozen. Everything moves. Everything evolves. Everything becomes something new. And we are living inside that story. So if you enjoy exploring ideas like this, the quiet, beautiful mysteries of space, subscribe to the channel and join me as we continue discovering how the universe really works.